Now, if it gets messed up, it's your fault. All right, 3.6, number 19. And if you look at that, it says take the derivative with respect to x. And then it's got all this stuff in parentheses. 2x minus 5 to the negative 1. I didn't work this one yesterday, did I? And then 4x plus 3 to the negative 2. If I did, it won't hurt to see it again. Now, the thing that I would do if I were having to work these to try to help you is I would put a big dot for multiplication right there so that you realize that you have the what? First term, second term, and you have to take the derivative. Fair enough? Okay. Y'all want to start on it on your own and then let me put a little bit more up there as you go? Okay? See if you can get just the derivative. See if you can get the derivative down. Yep. Take a look, see if you can make the derivative happen. I'm not going to tap on your desk and laugh at you if you're wrong. Well, I might. And we'll give you a few minutes to start, and then I'll start writing it on the board, and you can just look up and check it. And you know you're going to have to use your power rule when you take the derivative of this one, right? Got to bring the negative 1 to the front, write it down, subtract 1, and then remember to take the derivative of what's inside the parentheses. Don't forget that. So, time, see if you're happy. Big product rule. How's everyone on the derivative? Got good on the derivative? Now, if you wanted to factor it, what do you got to do? You've got to line up the plus signs, folks. Don't try to factor it. And when you write it across the page, you got to write it neat enough that you can work with it. But line up the plus signs. Put your brackets in. And then don't worry about all the little bits and pieces. Worry about the 2x minus 5s that are in both places. And when you factor out that 2x minus 5, you know you're going to factor it out to the lowest exponent. What's lower, negative 1 or negative 2? Negative 2. That's the key right there. So that one divides out, and this one leaves what? 2x minus 5. And negative 1 minus negative 2 gives you that pretty 1 out there, right? So you get 2x minus 5 on the right side of that plus sign. Is that all right? See, this one divided out completely, left a 1. This one, you factored it out, so you subtract from the exponent. Negative 1 minus negative 2 gives you a 1. And that's what you're hoping happens, and it will happen that way. All these parentheses will end up with just powers of 1. All right, you're going to factor out 4x plus 3. What power are you going to factor it out to? 4x plus 3 to what power?
Negative 3.
Negative 3. Because negative 3 is lower or smaller than negative 2. And this one will become 4x plus 3 just to the first. So far, so good. That's the hardest part. Then everything else after that is just what you already know. You've got a negative 2 here. Does everybody see the negative 2 here?
Yes.
Take it out, because you can also do what? Factor out the negative 2 there. And that's just going to leave the 4 right there. And then once you get to that point, simplify what's in the brackets. And you don't have to do this, but I think you're going to eventually want to know that that really works out to be this. This part right here with the negative exponents, just go ahead and take it down to the denominator. And put your negative 2 here. And 12x. Minus 17. And this would be very easy to work with, because if you set this equal to 0, you would set the numerator equal to 0, and that works out to be what? 17 over 12. Is that okay? See, you've got this now to where you can find where the derivative equals 0, where the slopes of the tangent lines are horizontal. You've got to that point. Pretty good? Is that a tolerable problem? All right. I want you to go down to 3.7, 3.7, and I want you to try your hand at number 23. 3.7, 23. There it is, right there. 3.7, 23. And look, notice what's different about it. It has what? It has fractional exponents. So 3.7, number 23. Just stepped it up because they went from having whole number exponents to having fractional exponents. I did work this one this morning, but it won't hurt to put it on the picture twice. 3.7, number 23. Do the same thing again. I'll put that dot between them for multiplication so that I'm trying to key in on using the product rule. Yes, and I'm giving you a moment to work. If someone's at home looking at this, this would give them a moment to work. This is the real video, not the made up to look good for TV video. This is me really up here teaching. No, I probably don't ask the right kind of questions. Probably not kind and caring enough, but my students learn. Write that out really big and pretty. I'm hoping you're gonna do most of this one on your own. That's what we're hoping. So I'm not gonna say a lot. Don't forget 3x squared over there on the other board. And that's your derivative. Happy? If you got the derivative right, that's a good start. Because if I asked you what's the slope of x equals 1, you just put a 1 in there, right? But now you got to simplify it. Back row. How you doing on simplification?
I'm just now starting it.
Okay,
honestly.
no problem. That's good. Is your derivative right?
Yes.
I like
I'll
that.
Check my derivative.
Yeah, because if that's wrong, nothing else is going to be a good day. I factored out 5 minus x squared to the negative what power? Negative 1/2, right? Negative 1/2 smaller than 1/2, is that right? Okay. Looking for shakes of heads like, yeah, that's right. Just keep writing, Evans. And you get a 1 above that one, don't you? And when you factored out x cubed plus 1, what power did you use? What power? Negative 3 over 4. Which made that 1/4 minus negative 3 over 4. And 1 comes out to be a power of 1. Then I worry about all the little stuff. Well, I don't really, 1/2, that's going to be a negative, right? Negative x right there. Okay? Now, since I see that negative x, I can go ahead and factor out the x, because there's also what way down there on the other end, an x what? Squared. I would just leave the negative sign in here. All right? You can just put a negative in front of the parentheses, or you can put a -1. And then I got 3/4 x over here. Okay? And some people don't like to have a fraction in here. All right? So what they'll do is, after they simplify it, they'll multiply it by 4. But if you put a 4 there, what do you have to put out front? A 1/4. All right? I don't mind having a fraction in there. Okay, some people don't like it. I think it's really complicated to have to sit there and multiply by 4 to get rid of the fraction and then bring it out. Do I need to simplify what's in the brackets? Everybody got that out front? Now, somebody says, Mr. Evans, I factored out a negative x. Well, that would have left this one positive, but it would have made this one what? Negative. Still works. That's good math. It still works. Okay. Ma'am? Yes, ma'am.
Where's the negative 2x go? I know that x is on the outside.
Got lucky. 1/2.
Oh, you just multiplied.
Yeah.
Okay.
And notice over here I had to get 3/4.
Right.
Yeah, I wish there would have been a 4 there, right? Yeah, no problem. Yeah, that's a good question. Because those are the little things that give us trouble. That's what we're working on now, is getting the algebra skills up. But we're doing the calculus with it. Now, what I will do, y'all want to look at 3/7 or 3/6? If you pick one, I will work, I prefer to work some kind of trig problem. That's what I'm looking for. But if you pick a trig problem out of here that you want to see work, you can look on your own phones if you want to scroll. 3/6, you see a trig problem you want me to work? Or 3/7, you see a trig problem you want me to work? 33 on, right here, this 33, 3/6. All right, let's take a look at it. 33, 36. 36. Big old quotient rule. Yeah, big quotient rule, come on. It's not too bad. It's gonna look bad, but it's not too bad. All right. 36, 33. Okay. F of y. So when we take the derivative of the y here, we're going to get 1 because it's going to be the change in y with respect to y. All right? F of y, function of y. So equals 3 sine 2y. And I've got to put that in parentheses just so I don't lose it. Otherwise, I get to looking at it and it doesn't. Cosine squared 2y, and then a plus 1 out there. All right. Who asked this one? Oh, thank God. Yeah. Okay. Draw me a long fraction bar. F prime of x equals
F prime of x or y.
F prime of y, yes sir. F prime of y. All right, write down the denominator and put a square above the whole thing. Square. Is that all right? And then what am I going to put right here? I'm going to put the what? The denominator, right? Yeah. Put in parentheses, write down the whole denominator. And then you have to take the derivative of the numerator. And you do not have to use the product rule because that is only what? A constant. So you don't have to use the product rule. So you're going to write down your 3, and then you're going to take the derivative of sine u. Derivative of sine u. And what is the derivative of sine u?
Cosine u.
Cosine u
du.
du. So we're going to get cosine 2y, and then just don't forget to put the what out there, the 2. All right? That 2 right there is what we always forget. Derivative of sine u, cosine u, du. Put your minus sign, write your numerator down. 3 sine 2y. Now, when we take the derivative of the denominator, and I want to make sure everybody's ready for the derivative of the denominator. Remember, that 2 right there means this whole thing is in parentheses with a 2 above it. We talked about that last time we were here. I gave you a whole. So you're going to bring the 2 to the front. You're going to write down your cosine 2y and subtract 1 power. So you're going to subtract, and that'll leave a what? A 1. But then you've got to realize that that cosine 2y was really in one set of parentheses with a square above it, right? So you brought the 2 down, you wrote it down, then you have to take the derivative of that cosine 2y. Okay?
Can you repeat that?
Yeah. Oh, let me do this. Let me help you out here. Let me help you out. Okay. We're going to take, we got cosine 2y and put a 2 above it like that. That's what that means. That 2 there really means all of this. So bring the 2 to the front. Write down the cosine 2y. It's now just a what? The first. But see how it's a big power rule?
Yeah.
So you got to take the derivative of that cosine 2y. And what is derivative of cosine 2y is what? Negative sine 2y times another 2.
Yeah.
And that's what I'm saying. See, brought the 2 to the front, cosine 2y, and then I have what? Negative sine 2y times 2. Did I get upset that you asked that question?
No.
No, see, I'm a kind man. And that's the kind of things that causes problem, because we've got to realize when you put the power there with the trig function, that's like a big set of parentheses with the power above it. Okay? And if you have to write it like that, there's nothing wrong with that. It helps you. You just have to write more steps.
So that plus one just disappears because it's a constant. And
That's
there's
right.
no derivative.
That's right. Very good. You saved me there, because I almost forgot to take the derivative plus 1.
Yeah.
So if that had been an x, it would have been real important. Okay. Now, here's the problem, is simplifying all that mess. And that's something you got to be able to do along the way. So, let's talk about that. Someone says, well, Mr. Evans, I might would distribute out this times the 1 and times that. I wouldn't do that yet. This is a case where I would probably do just the basic stuff. Just do some basics. All right. I wouldn't change. Only thing I would do on the first part, on the first step, is just 2 times 3 is what? 6. I wouldn't change anything else. 6, parentheses, cosine squared 2y plus 1. That's about got, there you go. Make sure I get all my parentheses in the right place. And then cosine 2y. And that's all I would do to this part right here. That's all I would do on the first step. Okay. You know, you love to skip steps, but imagine that this is going to be part of a problem that's a whole page or 2 long in the future. You don't want to skip steps and be in trouble. Okay? I'm not on the camera over here, am I? You got to take care of that, young man. Take care of that. All right. Now, see this negative and this negative? What kind of sign does that make between them? Just a what? Positive. And then I do have a 2 times a 2 times a 3, which would make 12. And then I got a sine 2y here, and I got a sine 2y here, right? Is that okay? Sine 2y times that sine 2y would become what? Sine squared 2y. Because I got this one over here times that one. Notice I'm not trying to do a whole bunch at one time. Sine squared 2y. And then the only thing left would be the what? Cosine 2y. And then I'm going to write my denominator down, just because